Today, August 15th, 2025, marks a turning point in medicine. It's a date that will be remembered for generations. A day when the impossible became possible, and the boundaries of science were pushed further than ever before. In a state-of-the-art laboratory in China, a dedicated team of scientists has achieved what many thought could only exist in the realm of science fiction. They have successfully grown a fully functional human kidney from scratch, using advanced biotechnological methods, and have transplanted it into a living test subject with promising results. This is no longer science fiction, it's reality. The dream of creating organs in the lab, once the subject of futuristic novels and movies, has now become a tangible achievement. For decades, building complex organs from scratch seemed impossible. The intricate structure of the kidney, with its millions of tiny filters and blood vessels, posed a challenge that stumped even the brightest minds in regenerative medicine. Now we have a real solution to organ failure. Patients who once faced a lifetime of uncertainty and medical interventions can now look forward to a future where their bodies are restored with organs grown specifically for them. Imagine a world where the desperate search for a donor is over, and dialysis is a thing of the past. No more waiting for a phone call that may never come, no more exhausting treatments that only buy time. This breakthrough is a beacon of hope for millions on waiting lists or tied to machines. It offers a new lease on life for those who have been living in the shadow of organ failure and for their families who have shared in their struggles. The Chinese team guided stem cells to form a working kidney, overcoming one of regenerative medicine's greatest challenges. Through precise control of growth factors and environmental conditions, they coaxed these cells to organize themselves into a complex, functioning organ. Their success paves the way for other organs to be grown, opening new frontiers in healthcare. The techniques developed here could soon be applied to hearts, livers, and even lungs, transforming the landscape of transplantation forever. For patients and families, this changes everything, from endless waiting to real possibility. The hope that once seemed distant is now within reach, bringing comfort and excitement for the future. The future is no longer about scarcity, but about planning and hope. Hospitals and doctors can now prepare for a world where organ shortages are a thing of the past, and every patient has a chance at a healthy life. Soon, failing organs could be replaced with new ones, grown just for each patient. Personalized medicine will take on a whole new meaning, as organs are tailored to fit each individual's unique biology, reducing the risk of rejection and complications. This is the dawn of personalized regenerative medicine. The promise of lab-grown organs is no longer a distant dream, it's the beginning of a new era in healthcare, where science and compassion come together to save lives and restore hope. Creating a lab-grown kidney begins with pluripotent stem cells, which are remarkable for their ability to become any cell type in the body. These cells are often harvested from the patient's own skin or blood, making the process highly personalized and reducing the risk of organ rejection. The journey starts with a simple biopsy, where a tiny sample of skin is collected and then reprogrammed in the lab to revert to a stem cell state. In the laboratory, these stem cells are carefully nurtured and exposed to a precise cocktail of growth factors and signaling molecules. This environment is meticulously controlled, guiding the cells to gradually transform into specialized kidney cells. The process requires patience and precision, as even slight variations can affect the outcome. Once the cells are ready, scientists employ advanced 3D bioprinting technology. This technique involves layering living cells and supportive hydrogels, following a digital blueprint that mimics the intricate architecture of a real kidney. The bioprinter builds up the organ's complex structure, including the tiny tubules and blood vessels essential for kidney function. The newly printed kidney organoid is then placed inside a bioreactor, a specialized chamber that simulates the body's internal environment. Here, the organoid receives nutrients, oxygen, and gentle mechanical cues, encouraging the cells to self-organize and mature, just as they would inside a developing embryo. Over the course of several weeks, millions of nephrons, the kidney's essential filtering units, begin to form. The scaffold gradually transforms into a living, functioning organ as the cells connect and communicate, establishing the networks needed for filtration and waste removal. Before the organ can be considered for transplantation, it undergoes rigorous testing. Scientists examine its structure under powerful microscopes and run functional tests to ensure it can filter blood and produce urine, just like a natural kidney. Only organs that meet strict criteria move forward. After passing all these tests, the lab-grown kidney is finally ready for transplantation. Surgeons carefully prepare the organ, ensuring it is sterile and viable for the recipient, marking a hopeful new beginning for patients in need. This entire process, from a single reprogrammed cell to a fully functional organ, represents a groundbreaking achievement in bioengineering. It's a testament to years of research, collaboration, and innovation. With each new organ created, scientists are rewriting what's possible, ushering in a new chapter in our ability to replicate and even improve upon life's original blueprint. The kidney is more than a filter. It's a dynamic organ, and replicating its functions is what makes this breakthrough so remarkable. Lab-grown kidneys can filter waste, regulate electrolytes, and reclaim vital substances like glucose and water. They also secrete hormones such as erythropoietin, correcting anemia, and help regulate blood pressure and bone health. Unlike dialysis, these organs respond to the body's changing needs, adjusting their function in real time. The Chinese team's kidneys integrate into the body's feedback loops, responding to hormonal signals. This dynamic responsiveness sets them apart from machines. It's not just about survival, it's about restoring the full spectrum of kidney function. This comprehensive replication makes lab-grown kidneys a true therapeutic revolution. The future of organ replacement is here. To grasp the impact of this breakthrough, consider the reality for patients with end-stage renal disease. Their options are limited: dialysis or a long wait for a transplant. Dialysis, whether in a clinic or at home, is grueling and only partially replaces kidney function. Life becomes a cycle of treatments, exhaustion, and uncertainty. The ultimate hope is a transplant, but donor organs are scarce, waiting lists are long, and many die before a match is found. Even after a transplant, patients face lifelong immunosuppressants and the risk of rejection. The average transplanted kidney lasts just a decade. For many, the journey is defined by waiting, anxiety, and compromise. This is the landscape lab-grown kidneys are set to transform. A new era is within reach. Dialysis, while life-saving, is a blunt tool. It can't match the kidney's round-the-clock, nuanced work. Patients endure cycles of feeling unwell, strict diets, and social isolation. Dialysis can't replace the kidney's hormonal functions, so more medications are needed. The emotional toll is immense. Many feel trapped by their treatment. Transplants offer more freedom, but the shortage of organs and risk of rejection remain huge barriers. Lifelong immunosuppressants bring their own health risks, from infections to cancer. Patients often trade one set of problems for another. Even a successful transplant is not a permanent cure. The current system is full of compromises. Lab-grown kidneys promise a way out of this cycle. Lab-grown kidneys represent a true paradigm shift in the treatment of kidney disease. For decades, patients have faced overwhelming challenges: limited organ availability, long waiting lists, and the constant threat of organ rejection. Now, with the advent of lab-grown kidneys, these issues are being tackled at their very source, offering hope where there was once only uncertainty. Instead of spending years anxiously waiting for a suitable donor, patients could soon have a new kidney grown from their own cells in just a matter of months. This revolutionary approach not only shortens the wait, but also personalizes the organ to each individual, reducing complications. Transplantation could become a predictable, scheduled procedure, allowing patients and their families to plan ahead with confidence, rather than living in limbo. No more desperate searches for a compatible donor, or enduring the harsh side effects of lifelong immunosuppressant medications. The risk of rejection is dramatically reduced. With autologous transplantation, using the patient's own cells, the body recognizes the new kidney as its own, virtually eliminating the threat of rejection and the need for powerful drugs. The psychological burden that once weighed so heavily on patients is lifted. Instead of fear and uncertainty, there is real hope, proactive care, and the possibility of a brighter future. Doctors could recommend transplants earlier in the course of disease, leading to better outcomes, faster recovery, and a significantly improved quality of life for patients. Patients regain a sense of normalcy, traveling, enjoying meals without restrictions, returning to work, and participating in activities they once thought impossible, all without the constant fear of health setbacks. It's not just about living longer, but about truly living better. cherishing moments with loved ones and embracing life's opportunities. The freedom from dialysis machines and endless waiting lists is nothing short of life-changing, opening doors to independence and new possibilities. With lab-grown kidneys, kidney failure transforms from a life sentence into a treatable condition, one where hope, health, and happiness are within reach for all. This breakthrough isn't just about kidneys, it's a leap for all regenerative medicine. The techniques used here can be adapted to create other organs, livers, pancreases, even lungs. Imagine curing diabetes with a lab-grown pancreas, or ending the wait for liver transplants. Lab-grown organoids also revolutionize drug testing, offering accurate human models for research. This could speed up drug development and make it safer. Healthcare costs could drop as chronic disease management shifts to one-time cures. The ability to generate organs on demand could transform healthcare systems worldwide. Resources could be redirected to prevention and innovation. This is more than a new treatment, it's a new philosophy of medicine. The ripple effects will be felt for generations. As exciting as this is, challenges remain before lab-grown kidneys become widely available. Scaling up production safely and affordably is a major hurdle. Long-term safety and effectiveness must be proven through rigorous trials. Regulatory agencies will set high standards for approval. Ethical questions loom: who gets access first? How do we ensure fairness? Public dialogue and strong ethical frameworks are essential. We must avoid widening health disparities as this technology rolls out. Despite these challenges, the global scientific community is ready to collaborate and innovate. The journey will take time, but the goal, a world without organ waiting lists, is within reach. The future of regenerative medicine is being built now. At its core, this story is about hope. Hope for patients dreaming of life beyond dialysis, and for families waiting for a miracle. The creation of a lab-grown kidney is a message: you have not been forgotten. Science has delivered on its promise, opening a future where organ failure is met with personalized solutions. Imagine hospitals growing organs on demand, tailored to each patient. The gift of life no longer depends on loss, but on our own cells' power to heal. The hardest step, proving it's possible, has been taken. This will inspire new generations to push medical boundaries. Today we celebrate a victory for science and humanity. A new dawn has arrived, bringing the promise of healthier, fuller lives for millions.